This is Charmaine Espinosa, and in this presentation, we will be sharing some results that we have generated from two experiments where we determined how excess heat can influence metabolizable energy and amino acid digestibility in corn. So, corn is shelled or harvested when the moisture content of the kernel is below 30%. But to store it safely, the moisture must be reduced to approximately 14 to 15%. Therefore, drying or further heat treatment is necessary to achieve this moisture requirement. At the moment, the grain industry reduces energy costs during the air force drying process of corn by applying temperatures that are greater than 100 degrees Celsius. And that is where heat treatment can potentially be termed as a necessary evil, since excess heat could negatively influence nutrient digestibility in corn. So this negative effect of overheating occurs due to formation of Maillard reaction products. So Maillard reaction involves the reaction of reducing sugars with a terminal or epsilon amino group of amino acids, and products of the Maillard reaction can render amino acids in diets and or feed ingredients unavailable. So the initial stage of the Maillard reaction consists of a sugar-amine condensation, and products of this reaction are further rearranged and converted to what we call as Amadori compounds. So formation of these Amadori compounds does not reduce concentration of amino acids. However, we typically observe reduction in amino acid digestibility in our feed ingredient. On the other hand, formation of melanoidins, which occurs during the final stage of the Maillard reaction, results in both reduction in the concentration and digestibility of amino acids in feed ingredients. So variations in heat processing, such as differences in temperature and duration of heating, may also affect the kinetics of the reaction. And how does this influence concentration and digestibility of amino acids and energy in corn? However, there is still limited information about how these certain factors influence amino acid and energy digestibility. Therefore, we conducted two experiments to test the hypothesis that the degree and duration of heating influence the standardized ileal digestibility of amino acids and concentration of metabolizable energy in corn. To conduct these two experiments, we used corn that originated from a single source, and this corn was divided into 11 batches that differs in how this single source of corn was heat treated. So 4 batches of corn were dried at 80 degrees Celsius for 1.5, 3, 24, or 48 hours, whereas 7 batches of corn were dried at 130 degrees Celsius for 1.5, 3, 6, 9, 12, 24, or 48 hours. We then analyzed these sources for amino acids, and this graph shows the concentration of analyzed lysine in our corn sources on a dry matter basis. Green bars represent sources that were dried at 80 degrees Celsius, whereas yellow bars represent sources that were dried at 130 degrees Celsius. So here we can observe that when corn is dried at 80 degrees Celsius, the duration of heating does not affect the concentration of lysine. However, when corn is dried at 130 degrees Celsius, the concentration of lysine decreases as the duration of drying increases. And when we look at gross energy in these sources, we have observed a slight increase in gross energy when we look at drying time from 1.5 to 3 hours, but in general, drying temperature and the duration of heating does not appear to influence the concentration of gross energy. Now, the question is how digestible these corn sources are and how temperature and time of drying affects these digestibility values. To shed light into this, we conducted the first experiment to determine the digestibility of energy and concentration of metabolizable energy in the 11 sources of corn. So a total of 88 pigs with an average initial body weight of 20 kilograms were randomly allotted to the 11 diets in a randomized complete block design with 3 blocks, 11 diets, and 8 replicate pigs per diet. These 11 diets were prepared by having each source of corn in one diet as the only energy-containing ingredient. So for this experiment, and also for the amino acid digestibility experiment, We use contrast statements in SAS to determine the linear and quadratic effect of drying time at 80 degrees Celsius, the linear and quadratic effect of drying time at 130 degrees Celsius, and to determine effects of two different heat treatment temperature. Now, this slide shows the apparent total track digestibility of gross energy in 11 sources of corn, and here we can observe that the duration of heating does not appear to influence digestibility of gross energy regardless of the drying temperature. However, when we determined how digestibility looks like between the two drying temperature, the ATTD of gross energy in corn sources dried at 130 degrees Celsius tended to be greater compared with that of corn sources dried at 80 degrees Celsius. And this may be a result of increased gelatinization of starch, which results in starch becoming more available for intestinal enzymes. And when we look at the concentration of metabolizable energy on a dry matter basis, corn sources dried at 80 degrees Celsius quadratically increased as duration of heating increases. However, when corn sources were dried at 130 degrees Celsius, the metabolizable energy tended to decrease as duration of heating increases. And this observed reduction is likely a result of reduced absorption of amino acids due to Maillard reactions and other detrimental effects of high temperature. Now, the second experiment that we conducted for this project determines how drying temperature and duration of heating influence the digestibility of amino acids in corn sources. In this experiment, we used 24 pigs with an initial body weight of 22.8 kilograms, and these pigs were randomly allotted to the 12 diets. These 12 diets consisted of 11 diets that were prepared by having each source of corn in one diet as the only source of amino acids in this diet. We also prepared a nitrogen-free diet to determine basal endogenous loss of amino acids for us to be able to calculate for standardized ileal digestibility of amino acids in corn. This slide shows the standardized ileal digestibility of lysine in corn sources, and at 80 degrees Celsius, the duration of heating does not affect lysine digestibility. However, the digestibility of lysine in corn sources dried at 130 degrees Celsius was reduced as duration of heating increases. This is likely a result of the observed decrease in the concentration of lysine, and these results indicate that corn dried at 130 degrees Celsius resulted in damage of amino acids due to Maillard reactions, in which lysine is the most reactive amino acid due to the presence of an epsilon amino group on the molecule that can react directly with reducing sugar under heating conditions. And due to the huge negative impact of excess heat in lysine digestibility, corn sources dried at 130 degrees Celsius also had reduced digestibility of lysine when compared with corn sources dried at 80 degrees Celsius, which is 71% for 80 degrees Celsius and 62.7% for 130 degrees Celsius. When we look at methionine digestibility, it appears the duration of heating does not influence methionine digestibility in corn sources dried at 80 degrees Celsius. However, a linear reduction was observed for corn sources that were dried at 130 degrees Celsius as duration of heating increases. But when we compared the two drying temperatures, no difference was observed. Similar results were observed for the threonine digestibility, where duration of heating does not impact digestibility when the heating temperature was at 80 degrees Celsius. On the other hand, threonine digestibility was linearly reduced as drying time increases in corn sources dried at 130 degrees Celsius. And the same as methionine, no difference was observed when compared with corn sources dried at 80 degrees Celsius and corn sources dried at 130 degrees Celsius. So overall, in terms of comparing the two temperatures, we have observed that corn sources dried at 130 degrees Celsius had less concentration and had reduced digestibility of lysine compared with corn sources dried at 80 degrees Celsius. However, the digestibility of other amino acids were not different between the two drying temperatures, which demonstrates that lysine is the most susceptible amino acid to Maillard reactions. Metabolizable energy, on the other hand, is greater in corn sources dried at 130 degrees Celsius compared with that of corn sources dried at 80 degrees Celsius, we have demonstrated that when corn is dried at 80 degrees Celsius, increased drying time does not influence concentration of amino acids on a dry matter basis. Increased drying time does not also influence digestibility of amino acids, indicating that corn sources dried at 80 degrees Celsius were not heat damaged regardless of the duration of heating. The concentration of metabolizable energy, on the other hand, increased by increased drying time. When corn is dried at 130 degrees Celsius, we have observed that increased drying time resulted in a reduction of both concentration and digestibility of lysine. Increased drying time also reduced the concentration of metabolizable energy in corn sources dried at 130 degrees Celsius. And this just tells us the negative consequences of overheating our feed ingredients not only in amino acids but with energy as well. Therefore, if heat damaged corn is included in diets for pigs, it is necessary that extra energy and extra amino acids are included in the diets to avoid the negative impact of heat damage on growth performance of pigs. Thank you for listening and for your interest in this presentation. And if you would like to know more about nutrition, you could visit our website at nutrition.ansai.illinois.edu.